What if you woke up this morning and there was no electricity? What would you do? And how would that affect your daily routine? Our planet has been depending on electricity for many years. Imagine that all going away. Our work has been done by electric tools and machines. 150 years ago, we would use things such as horses and mules. Do you know how the electricity gets to your house? And how does it generate? We're going to find that out in our lesson on electric currents.
Current electricity is the continuous flow of electrons. Electric current powers all electrical appliances, as well as being able to heat and cool your food, cook your food, and provide you with information. Electric current travels to your home through a system known as a power grid. Power cables and poles in your neighborhood are visible parts of power grids in most cities, towns, and rural areas. Most of the electricity that is transported through the power grid comes from power plants. The power plant's generators are likely powered by a system engine, running water, or a diesel engine. From the power station, this electricity is fed into a network of wires. Its power is boosted to allow it to be transmitted. Can you explain how electric current reaches the outlets in our homes?
When an electric current flows, the electrons all move in a continuous and unbroken path. There are two main types of electric current: direct current and alternating current. Direct current flows in one direction. This current is used in batteries. Alternating current, the electric current that we obtain from outlets. This current changes direction because it is produced at a power station using a rotating current generator. The flow through wire can be thought as water going through a pipe. Just like the water in the pipe is under pressure, is known as voltage, and it is what drives the electrons through the wire in a given period is the amperage. The unit for measuring the flow of electricity. Remember, the voltage of the current is a measure of the force that pushes the electricity through a wire. The amperage is the measure of the rate at which electricity flows through the wire.
How does electricity move through different materials to power your computer? What substances allow electricity to pass through? Matters react in various ways to move electric charges. Conductivity refers to a material ability to allow electrons to flow. When the material
An insulator is a material that resists or blocks the flow of electrons to move freely from an atom to atom in a continuous path. The conductivity of materials ranges from those that are the least conductive and make the best insulators. Liquid solutions, especially those that contain salts and acids, also make good conductors. Even objects that are normally good insulators, such as a dry tree branch, will conduct electricity when wet. You have probably seen or read the warning labels on electric appliances warning you not to use them near water. Pure water is generally considered to be a non-conductive material. Tap water and most fresh water, on the other hand, is a good conductor. The impurities dissolve minerals and salts that are present in tap water but absent in pure water affect conductivity. The dissolved minerals make up tap water, and mostly fresh water, a good conductor. So touching an appliance such as an electric hairdryer near a bath or shower could put you in real danger. The water could not conduct an electric charge to your skin and cause serious electric shock.
Superconductors are materials that conduct electricity without any loss of energy due to resistance. The low resistance quality of superconductors is because their electrons are bound together in pairs and flow with extremely low energy loss. This creates an electric moves with little resistance. Japan, Germany, and China have already built maglev, or magnetic levitation train systems that use these superconductors and the technology. Associated with them and other use of superconductors in the materials is in a cross-sectional magnetic response imaging, known as MRI, of the inside of the human body. Insulators are materials that have tightly bound electrons. These materials strongly resist the flow of charges. Common insulators include ceramics, glass, plastics, rubber, and wood. Insulators often used to protect us from dangerous transmission lines. For the same reason, a plastic coating is often placed around electric wires on appliances to use to conduct electricity.
We will wrap up this lesson by repeating some questions mentioned in this video, including the details and procedures used in this video try answering these questions. Explain how electric current reaches the outlets in your homes. Question number 2. What is the electric force called that drives electric current through wires? Question number 3. Silver is a better conductor than aluminum. If a silver wire and an aluminum wire have the same length and the same thickness, which will have a higher resistance? Explain how the width of the wire affects conductivity.